I've now added several catch basins to the project, and we are going to add catchments to start generating flows into our storm sewer. To do that, we're going to go under Flow Inputs and click on the Storm Catchment button. We're going to add a catchment into our plan view. When you add it in, you'll see it's going to automatically start previewing a blue arrow, and you'll click on the discharge location for this catchment. So in this case, the catchment is going to run off into this catch basin into the storm sewer. Now you'll notice that this catchment is currently red, and that's simply because an area has not yet been assigned. So to assign an area, there's two options. One is you can set the area and runoff coefficient manually. To do that, you simply click on this box, and then you are free to update the area and runoff coefficient to whatever value you see fit. You can also update the time of concentration value. However, the preferred option is to leave this unset, and you're going to actually edit the land use table. So when you click on this, you will be presented with a table that has various land uses, the corresponding runoff coefficient, and then the actual breakdown of those land use areas. So typically you would have already calculated this in a drainage plan in AutoCAD. And then instead of entering them into Excel, you would enter them in here. Now, there are three different land uses just by default, but you can customize these for your projects. To do that, you come here to the Land Use Manager button. And when you do that, you can now add in extra rows. So for example, I can click here and say gravel, and I can assign this a runoff coefficient of 0.7. You can also import and export your land use tables to reuse on other projects. So now that I've added in that gravel land use, I can now add it to this specific catchment. And what I'm going to do for this site, we're going to say we've got a little bit of lawn, let's say 0.1 hectares of lawn, and the rest is mostly an impervious surface. Let's say 0.4, like that. And so what InterHyd is going to do is it's going to calculate the composite runoff coefficient, and it's going to start generating a peak flow into the storm sewer. Once you've added multiple catchments to your design, in this case you can see here I've added about 6 catchments, you'll see that the pipe sizes are going to automatically update. So in this case, this pipe is now a 675. And what's happening is all of the flows that are being generated from these catchments, it's going to be doing the rational method runoff. It's going to do all of the pipe routing, and then InterHyd is going to select the smallest pipe size that will satisfy the percent full flow criteria. So in this case, this is going to be a 675, and InterHyd is selecting it from this list. If you were to override this and select a smaller pipe, like a 600, you'll see that it highlights red. When you click on it, it's going to tell you specifically what the issue is. In this case, the percent full is 95%, and that's higher than the criteria that I've got this set at 90%. So to reset that, you simply click the lock icon, and InterHyd will recalculate what that minimum pipe size is supposed to be. If we take a look at the profile view, you'll see that all of the pipe sizes have been updated, and InterHyd is still automating the design by connecting obvert to obvert and maintaining the locked elevations that we have previously set.